Hello everyone. It's really great to be here again. As you've noticed, I'm going to talk in English, so people can have more sessions to actually listen to. Okay, so today I'm going to talk about delivery pipelines and plumbers. So maybe a bit weird topic for an IT and testing conference. And before we begin, a small disclaimer: the author of the slides is not a professional artist. Art is a very subjective thing. They were made with love, so please judge them accordingly. So before we begin, if I would ask you a question, if I would give you a pen and a whiteboard, would you be able to actually draw how are you delivering your software in your project, in your teams, in your company? What are different elements and what actually happens after developers put some code into their computers and till your application reaches production and your users start to interact with it? Hopefully after this presentation you will more likely be able to get some hints about answering this question. So we very often focus on what? On the application that we are building, right? We love to talk about our apps because there are different ones, but they are glorious ones, right? These are the applications that we are proud of because we made them, so they are the best ones. But the delivery pipeline is about how. How are we actually building everything around that application? So usually there are lots of different people involved in that. We have some designers designing these applications, right? We have some developers developing the features, then figuring it out why is it working, then figuring out why it's not working, and interacting happily with this happy tester who is always happy because it usually does not work accordingly to the expectations. And there are other people involved in software development as well. There are managers, constantly pissed because the rest of them, it does not deliver on time, missing deadlines, things like that. And they also impact the way we develop software. So there is a lot of interactions with the application, but also between different team members. And why do we do that? Well, because we have those pipelines that we can abstract from this flow. And we do this because there are some users at the very end of that journey that supposedly have some problem that we are trying to solve with software. And at the end of every delivery pipeline, whatever your niche is, there is a production with there's also some problems that we are trying to solve for our end users. So this is roughly what we do in software development, right? So like abstracting it further, we have an aquarium that we are trying to fill in with some sort of liquid. And what is the liquid that we are using in software? Coffee. Yeah. Maybe some of you thought about different types of liquid. I'm not judging. I also saw some pretty bad code. But yeah, developers are digesting coffee and producing code. And basically the simple diagram shows the whole software development. There is supposed to be a problem that we are trying to solve with code. Very often it sometimes happens that first we develop some sort of application and then try to find a problem, right? But yeah, this is how we try to innovate some stuff. So here we are. Here we have our happy plumber wanting to develop a delivery pipeline. And this is something that we're going to do today over here. So let's build one. To build the pipeline, we're going to need some parts. And these parts are in the boxes. So let's open the first one. And what are the elements of the pipeline? Like, what do you think can be used to assemble a pipeline? Some technologies, maybe. But in my first box, there are people. And like fully assembled ones, not body parts or nothing weird. These are people. And this is basically the hardest part you're going to encounter in software development. So we have some developers, we have our business stakeholders, so we have like your average Joe's users that are not really special but are there. Sometimes they are working in a corporate environment, trying to be happy, working from their cubicles. Sometimes they are chilled out teenagers, not caring about anything. And sometimes we work in a more regulated business, for example, for banks or other financial companies. And if you're working in a large organization, you're going to probably be working with other teams, either within your company or outside with some third parties that you also interact with. And then we can move to the easy part, the technology. First of all, we have environments, right? So all of you have at least one. It's the production server. For some of you, maybe this is the only environment that you have. It's also a test environment, UAT environment, all the environments that you can possibly do, you do it on production. And it's 2020, so joking about testing production is not really a thing to do. It's a valid technique to actually test some stuff. But it's also good to have some sort of integration server, some test server, where we can actually do that before we push something to our users, so we do not embarrass ourselves or lose money. Sometimes we also want to validate other aspects, like, for example, performance. So we tend to have additional machines somewhere next to our production where we stress test because we want them to perform really well, or a UAT environment where we put our business stakeholders so they can happily accept what we actually developed. And then we have steps that we usually group in stages. So we have different ones, right? We have some checkout steps, we have some build stages and deployments, all of that. And most of you are probably familiar with the next type, which is quality gates. And when I was drawing this diagram, I thought that basically we have two. We have ones that are basically valves that you can shut down, cut the flow of your fluid so it does not progress any further. Those are the Gandalfs of your pipeline. And then you have some sort of filters or sensors that basically do not block anything but simply say that, well, we have a problem in coming somewhere down the pipe. So basically these two types, and these will be test automations. Some additional manual steps that we sometimes include, like accepting by business, approving by some audit team, right? So this can take various forms. And then there's this magic pipe that is basically filtering and turning any liquid, and this not necessarily in this context is the coffee, into a pure water that actually, you know, makes your code perfect and amazing. Unfortunately, that's not true, at least yet. We do not have self-healing applications, so it is really important to take care about what you actually put in your pipelines, because it's not going to fix itself. So it's really important to pay attention to that. Maybe in the future we'll have some AI doing that for us, but for now, no magic pipes. And then we have other elements like artifacts. And on previous presentation, Julian was talking about APKs, for example, for Android. So you package your applications into APKs. You have jars in Java world, right? You have zip packages, tarballs. It can be anything, like Docker images. And we store them in some artifact storage, so we can then use them on different environments. And of course, we have repositories where we store our code. So a lot of talking, and maybe let's build the pipeline finally. So step number one is to understand your context. And fans of context-driven testing school are happy because they already do that, but this will influence understanding boundaries within which you operate, will modify the way you approach delivering software. So there are basically four important aspects that I want to focus right now. Usually you have some sort of problem, or at least you should have, that your customers are having, right? Then the most important one is the budget, because it's fun to actually solve some problems, but it's also fun not to starve each month, right? So the money is kind of important for us. And then there you have a development team that is supposedly building a solution for that problem. So for our example right now, let's assume that our customers are a group of students that want to solve mathematical equations. So their problem is that they don't find a good online platform for solving mathematical equations. And we found an angel investor from San Francisco who, you know, is hustling 24/7, 24 hours per day, microdosing LSD, and he hustles a lot of businesses. And we have our development team, a group of friends, John, who's a back-end developer, Sarah, who's front-end developer, and Joe. Joe is a designer, a very chilled man, and not because he's digesting some chemical substances, because this is how he is. And he's a fan of an MVP concept, and which will be important right now, because the step 2 is understanding what we are building. And very often I see that people not necessarily know what they're building, they're focusing on features and they don't know the bigger picture. So over here we are focusing on what. And once again, our problem is solving mathematical equations, right? So Joe designed a prototype that we're going to deliver in the first iteration. So our glorious application will be this magical online platform for computing. And we have 9 buttons, 2 operations, and a display showing the results of those. And it's not that I was too lazy to draw more buttons, that there is no 0 and other operations. This is an MVP concept, so it's justified in this case. And what about the structure of our app? We're going to have a user interface written in React, and then we're going to have backend services, microservice for each button, because our development team is a fan of microservices. Everyone does them, so let's do it over here. So each button will have a corresponding microservice written in Spring, so in Java, and they will talk with each other. Is it over-engineered? Is it over-complicated? Perhaps, but this is what we do in software development as well, and you will encounter a situation like that. Because if you sometimes think about the problems that you are trying to solve and look at the solutions, there are some crazy ideas from flying around, but hey, unless someone stops paying, that's not a problem, right? And of course, it's 2020, we do everything in the cloud, so we are gonna put that in some cloud services, and we're gonna apply also, attach some database, so our backend will persist all those fancy calculations that our users are gonna do. Okay, so we know what we are building, right? We know our context. Let's design the pipeline. And it all begins with a development process. So how are you actually building the software? And this includes various methodologies that you're going to use, right? So we know the technologies, but are we going to use, for example, TDD, ATDD, BDD, whatever DD you're going to come up with, or here at the conference? How are you going to approach development process in terms of quality? Are you going to do some code reviews? Are you do some mock programming? Are you going to apply other extreme programming techniques, for example? How are you going to test the application? So who's actually going to do it? Because as you saw, there's no tester or QA on the team. And then it all ends up in a repository. So we are picking Git, one of the most popular control version systems that everyone is so familiar with, right? 3 commands: git add, git commit, git push with a force, and that's it for you. And one important aspect is related to Git. Which we often overcomplicate a lot. It's Git flow, right? So how you structure your branches in your repository. And this is one of the interesting indicators for me when I encounter different teams, is that they very often overcomplicate it. So there are bazillions of branches, you know, overcomplicated engineering, like you have like tons of instructions how to actually start development on the feature, and this is a signal for me that they're trying to prevent problems before they even happen, and actually they're gonna run into more problems because of that than they think. So I'm a fan of a simple one. So we have a master branch with some feature branches. Some people go even further. There is a concept of trunk-based development. So we aren't using any branches. We are directly committing to trunk. If you think that that's crazy, well, this is how Google does things. This is how Facebook does things. So you know they know what they're doing, right? And then another decision it needs to be made, because we have a front end, right? Written in React. We have a number of services, around a dozen of them, and we can either keep them in separate repositories with their own development life cycles, or we can put everything together in a single mono repository and then handle only a single repository. Both of these approaches have their cons and pros, but you have to decide at the very beginning, because it will impact the way you design your pipeline. So if you think this is crazy and messy, again, Google and Facebook, this is how they do things. They have thousands of developers committing to a single repository on trunk. It can be done. And our development teams went to our development team went to a conference. They saw how Google does things, and they're gonna go with mono repository. So the diagram that I'm going to draw next is way simpler than handling multiple repositories. All right, then we have our code in the repository, and the first step is there, right? So we check out the code on some runners. It can be either done manually or automatically. It's up to you basically if you're gonna press the button or want to have some webhooks talking with your Git hosting with the build server and triggering the builds automatically. It's up to you how you're gonna handle that. And then we move to the next stage, which is really sometimes complex, the build stage. And in the build stage, build tools are important. So we have React application. So we're gonna handle dependencies, all that with Yarn. And then we have backend written in Java, in Spring. So we're gonna use Gradle as our build tool. And it's not like they live separately, because often what we do is mix those two systems. So Gradle is actually going to run Yarn in one of the tasks, because then you have a nicer development experience because you are using and interacting only with a single tool normally, unless you're Sarah and you are developing frontend. So then, having that, we have two sub-pipelines inside. We have the backend one and frontend one, and this is oversimplification, but because we have multiple ones for each microservice separately, so we can actually test all that in parallel and shorten the delivery. So we are compiling the code or processing the code in some way, and then we have unit tests, because our team loves TDD and they have lots of unit tests. And for Java, we're going to also apply a very cheap technique to increase the quality. We're going to run some static code analysis and push the results into SonarQube server, where it's going to process and say that we are having a really nice code without any violations or security breaches. And after that, we end up with artifacts. So we're going to package the front-end app in a zip, and then we have a bunch of jars containing all those microservices that we're going to put in some artifact storage. Now, we have our artifacts, right? And then we have our very first environment to which we can deploy those artifacts. And the deployment stage is not really a single script very often, because the deployment process can be complicated. Because if you have the application hosted across multiple servers, for example, you have some load balancer in front. So you disable one zone, enable another one. It can be a really complex process. There are sometimes some post-deployment steps that you want to clear a cache of your application, want to set the database in a desired state. And also you need to know that the application is up and running, so you want to introduce maybe some health checks during that process. So it can be a complex one. And we have our environment, the integration server, which we want to control. You want to control your environments, otherwise you might run into some problems, because you won't be able to tell if this is your application or this is the deployment failing. And there are concepts that help us with that. We have infrastructure as code. We have configuration management. So we're going to use Terraform as a tool for infrastructure as code. We're going to write some scripts that will set up like EC2s in AWS. And then we're going to use Chef as our configuration management. And Chef has something called Test Kitchen that you can write tests, because this is code, so we can test code automatically. We might want to have some automated tests checking our infrastructure, so it's all automated, no human errors, and everything's good. If you don't have that, once again, you might run into some leaky environments, and you will be running around and wondering if, well, it was deployment that caused the failure, or this was Joe installing a new Java version because he wanted to test some stuff and did not tell about that to other team members. Okay, so we have an application up and running, right? So what we can do is we can finally test it, and we can basically run some test automation on that. So everybody loves to write automated tests, right? So we're going to write a bunch of Selenium scripts. And since Selenium is requiring some browsers to actually operate on, we're going to have to set up a test infrastructure. So we're going to run a number of Selenium grid nodes, and we're going to also do it on our own, because we don't trust all those cloud services with our precious data. So we want to set it up from the very ground. And one important thing here, this is like a proper infrastructure element of your whole system. So it's not a second-class citizen that you're gonna, set up on your local machine and fire from time to time. This is an important piece, and you also need to control that. So the concepts of infrastructure as code, configuration management also apply here, and you need to treat it as one of your environments, because otherwise you will have flaky tests, you will run into some maintenance issues, and again, you won't be able to tell if this is the pipeline failing or your infrastructure giving up. Okay, so again, we have an application up and running, so we can do some user acceptance testing, right? We can grab a stakeholder and show him our application, do a demo, and get some quick feedback very early on during the process, and they will tell us if we can proceed with our prototype further, or maybe there are some things that we might need to improve. And other aspects that we want to validate, because over here we check the functionality, if it's working correctly, right? But is it working in a performant way? So this is an online platform. There are millions of users having problems with their mathematical equations, right? We expect millions and millions of users. So we want to run performance tests, and we want to include that in our delivery pipeline. So we're going to spawn an additional environment called perf, and we're going to spawn some load runners, because we want to make sure that there is everything all right with our application in terms of performance. And we're going to use locust, because basically we don't have Python yet in our technology stack, so let's add that one. It's working correctly, it's working performantly, so we can actually deploy the code to production and make our users happy, so they can solve those mathematical equations, and we can observe them. And this is something that Julian was talking about. You can actually, this is not the end of your pipeline, because you can start observing how your users work on your application and gather some feedback from that. So analytics, monitoring, and actually you can see if you build the correct thing or not. So this is our pipeline with all the infrastructure that is supporting the pipeline. So not only environments, but also the blocks that we have built as SonarQube, Selenium Grid, load runners, and analytics, because once again we are building the analytics from scratch. We don't trust Google because privacy issues. So we're gonna run our own service. And finally, we can implement the pipeline. So nowadays you have lots of concepts like pipeline as a code. And we talked briefly before this talk that there are various systems that allow you to do this. So we can define our pipeline as code. And in Jenkins, this will be Jenkins files with some groovy DSL. You can use the most popular format for everything, very popular in the format that's making people using Kubernetes very, very happy. So YML files, right? You have those large files describing your builds in systems like Travis, GitLab, or others. And you can, again, describe this as a code, and then use it in your build system. We are going to use Jenkins, so our team, our dream team is fan of open source solutions, so they're going to use Jenkins. Since this is a code, we can store that in a Git repository, right? And then check it out and feed into Jenkins itself. And this is when you actually realize that you have created additional pipeline. And if you stop right now for a moment and analyze what has happened in our design process, you realize that you have defined your pipeline as a code. Great. You have defined your infrastructure as a code. So all the blocks are, again, small applications that you deliver as well. The pipeline, digesting the pipeline, can also be defined as a code. So we can create in Jenkins some seed jobs that will digest those definitions and automatically spawn all these builds. And this is when you actually realize that you have one application to deliver, but you have built dozens of smaller ones that you actually, right now, need to maintain. And this is a problem and something that you might not realize, because this is usually a simple task, like build a Jenkins job, right? Easy. But then again, when you start doing all those fancy things, you run into some maintenance issues. And one important thing is that automation is expensive. yes, it helps us a lot with quality because there is no room for human errors, right? You have everything coded, running accordingly. You have test automation validating all that procedures, your deployments, your infrastructure, all these elements with code. So there's no way that John, for example, will forget about step number 8 on the deployment checklist because everything is automated. And one important thing is don't feel compelled to actually do that because you can do it without automation. You can have some procedures, right? You can have some rules in place that will prevent that, but you need to be more, rigid with enforcing them. Because you can have a checklist, you can have a series of bash scripts doing the same stuff. And this is actually a situation that my current project has. Because part of the configuration management is being done by the client, and the remaining part of the configuration management is done by third party that is actually hosting our platform. So we do not have control over either part of the system, so we are in between and we need to modify the environment to actually include some additional dependencies, some additional packages. So sometimes we ping them, hey, please add this, and they do that, but we don't see the effects, we only see the result in the actual environment. And it's a painful process, right, because collaboration is really costly. And we written a bunch of scripts filling the gap that we also maintain, but we don't have chef recipes anymore. And this is like a bit of a regression to what we had a couple years ago. And what is really important is that there are elements that we haven't even talked about, like log management, because you want to monitor the whole system, feed that into one place, right? You want to discuss versioning. How are you actually versioning your applications? Are you using semantic versioning? Are you using build numbers? Are you using something other, something crazy? We have launched applications because we haven't thought about versioning, and they are up and running probably till this very day with a 0.0 snapshot version on production since a couple of years. So that's maybe not really important thing, but if you have dozens of microservices and you want to, draw a table where you correlate the versions of specific microservices to specific version of front-end application, you need to actually think about it. And then dependency management, because you might run into some issues in that area, or notifications. How are you actually going to notify your development team or the users about different failures that are happening throughout the pipeline? And then there are the matter of reports, so how much data actually do we surface to our users, to our development team members, and are they actually readable, or there is too much information, maybe something's missing. So there's a lot that we have not unwrapped yet, and as you can see, this is a complex machine. This is a complex process. So it's really important to also talk about quality assurance approach to this, because it's an application. Right? We have number of apps building different servers, building the whole pipeline. And we can think about different metrics, because there is like some DevOps metrics that you can track. There's a change lead time. So how fast can you actually deliver a feature after the developer has entered the code to the repository? How long does it take to actually reach production? Are you doing it fast enough? Or maybe your competition is faster, quicker in responding to feedback from their users, and they're going to outsmart you on the market. So we can track time of each stage and see that maybe we can parallelize some stuff. And also, maybe not everything is important, because, for example, we want to change a label on our calculator, right? Do you want really to run performance tests for a change in a label? And very often people are basically just clicking the button, not actually understanding what the change is. So you want to also make the pipeline a bit smarter and maybe make this step optional for front-end changes. Maybe you want to parallelize your testing, or maybe remove it totally. So there's also a metric that is worth tracking: change failure rate. How often does deployment to production result in a total failure? Because this directly connects to loss of money, and you want to maybe track that, because it indicates that something went wrong along the pipeline, even though you reached production. But maybe you have not enough tests, not enough filters in your pipeline to actually weed that out. And something that every test automation engineer loves, right? Green, red, and maybe it's fine for you to have that because hopefully this is working and picking up issues within the process. But maybe you have a situation where green are not really okay because someone disabled the tests, and this is like example from real experience where everyone was so happy. We have a huge system for delivery pipeline, and everything was alright. They were clicking buttons. Builds are always green. Everyone's happy. No one actually thought that tests usually took like 15 minutes. Now they take like 1. What's happening? And what was happening? Someone actually disabled the whole stage. Everything was happy, right? Because do you care about green balls in Jenkins? Do you actually investigate if everything's passing from time to time? Usually you don't, right? You expect a green, so you're happy, and suddenly you realize that you are not running tests for, I think it was 2 months. So, it's nice to have all that expensive automation, but then you need to also go back and validate that. And reds, again, maybe you have some issues with configuration management because your environment is not stable enough. Maybe your tests are basically crappy, and you are actually hurting yourself because what usually happens when people see a red light in Jenkins? Run it again and see if it fixes things, right? And then you see a green, everything's okay. So you don't investigate those failures. So this is an opportunity to stop and actually analyze what is happening. And yes, it is expensive because who cares about that, right? We need to develop features further and further and further. We don't want to stop and actually investigate what is happening. Hitting the button again solves the problem, right? Unless this happen again on production, then the boss will call and, hey, what's up? And you realize that, well, you had the same issue a couple months ago. So quality assurance can also be applied to this whole process. And the question is that usually you need to ask yourself, who is actually managing that? Are those DevOps engineers in your organization? Are those the backend engineers, front-end engineers, quality assurance engineers? Who is actually taking care of your delivery pipeline? Who is your plumber in your organization? Who is actually investigating all that stuff? Are you tracking that with different tickets? Do you have a retrospective for the state of your pipeline? Because we care about the application, not necessarily how we develop stuff. So hopefully after this presentation you're gonna have some nice background, or at least some hints about elements that you want to actually have a discussion with your team. Sit down and try to stand next to a whiteboard and draw together a system. How are you delivering this system? What is actually happening throughout your delivery pipeline? We did the same example in one of our projects where we actually did something like that after 2 or 3 months of developing software together. Half of the team had no idea what is actually the high-level architecture of our application, not even talking about how we deliver that. And they thought, there's always this Jenkins build that someone runs. I have never actually logged into Jenkins. There are people like after 3 months that, yeah, I know that there is something running, but the QA engineer is always coming and saying that, well, build failed. Have you actually saw the logs? No, not really, but they say that build failed, and they submit a ticket in Jira, I'm fixing the bugs. So draw your delivery pipelines, because it's a really nice exercise to actually pinpoint some issues throughout your delivery process. So that's all from me. Thank you very much, and I'm open to any questions.